Good day, everyone. This is Master Intellectual Tutorials, and today we continue from our previous video, which we were talking about functions. All right, so functions now. We talked about mapping in the last video, and this video looking at functions. So what are functions? Functions are just like mapping. Also, they are a relationship between two sets. That's a function. That is, for instance, let me give a function here. Let's say we have a and we have b there. So I know that this is let's say this is 2, this is 3, this is 4. So this is let's say this is 4. Sorry, let's say this is 4. This is 5, and this is 1. So a function is a rule that assign each element of A to an element of B. That is, it assign element of the domain to an element of the co-domain. So this is a function f there now. So, and I already said in last class that these are the range R. The range R are the elements in your co-domain that are images of elements in your domain. What am I saying? 4 is an image, 5 is an image, 1 is an image. There. 4 is an image of 2, 5 is an image of 3, 1 is an image of what? 4. There now. Why 2, 3, 4 are elements? I get it now. And your range are all your image, your combination of all your images is called your range. There now. And also, yes, so the range here is 4, 5, and 6, and that's what range is about. So that's what a function is. Now this is just a typical example of a function. Now first of all, let me start with this. What's the difference between a function and a map? A function and a map, what's the difference? Now for a mapping, for a function, the only difference is that a function, the only difference between a function and map is that your element in your code domain are numbers. A function is a map whose code domain, that's another definition, whose codomain are set of numbers. So when your codomain becomes a set of numbers, then it becomes a function. It no longer becomes a map anymore. Do you get it now? So that's what the difference is right now. Now let's look at a typical example of a function. Let's say we have let me use let's say we have something like let's say we have something like 1 year. Let's say we have something like another 1 year. Okay, so and we have a, sorry about that, we have a and we have b. I like using b. I get it now. And this is f. I get it now. So let's say our f, no, we said function is a rule that associates an element of a to an element of b. That is, this is what relates a and b together. So it must be defined. Let's give an example here. Let's say we have f of x equals to x squared. Let's say this is the example given, and we want to find the corresponding element. So what will be our f of 1 here? Our f of 1 will be 1 square, which is 1. So that means 1 here and 1 here, 1 map to 1. I get it. F of 2. In this case now, our f of 2 will be 2 square there, which is 4. So 2 is mapped to 4. I get it now. So and let's say we have f of 3, which is 9. 3 mapped to 9. I get it now. So a function is basically a rule that assign an element of A to an element of B. So a function is basically like a formula, just like a relation that says that okay, when this one is one, this one will be one. When this one is two, this one will be four. When this one is three, this one is nine. Based on this rule that we are given, I don't know. So this is the rule we are given here, and this is the function. So a function is like a rule that assigns an element of A to an element of B. Alright, so having known that already, now, there are some things you also need to know. Now, if you look at this now, this is f of x. I get it now. This is f of x here, and this is the rule here. Now, this x inside, it comes from your domain. I get it now. So when x is 1, can you see now? It gives 1. When x is 2, it gives 4. When x is 3, it gives 9. And this is your solution, which is f of x. It comes from a co-domain. Now, this brings us to the next subtopic, which is called, which we'll be looking at, which is called variables. Variables. So what are variables? Variables. So what are variables? What are variables? So a variable is just like a quantity that can take any numerical value, or a quantity that can take any numerical value, like a constant. A constant is just one value because it is just an exact number or whatsoever. But a variable can take any numerical value. It's just like a quantity that can take any numerical value. So when you have a function f of x equals to, let's say, s cube, this f of x equals to s cube, I can write it as something like y equals to x cube. Am I right? I can write it like something like y equals to s cube. I don't know where this y represents your f of x and this represents this here. I get it now. Now, variables we already define variables as anything that can take a quantity that can take any numerical value. In this case here, y is a variable, which is same thing as your f of x, and also your x raised to power 3 is also a variable, which is known as, which is same thing as s cube here also. Can you see it now? So we already know what the variable is. There is something that can take a quantity that can take any numerical value, but there are also types of variables, and this one you need to know it. As a mathematician, you need to know this very well because you are going to apply it in different scenarios in mathematics. So that's why it's very important for you to know what variable is. So variables are divided into majorly two. We have what we call the dependent variable, and we also have the independent variable. That's independent variable. Can you see now? So we have dependent variable, we also have the independent variable. So in maths we have two kind of variable, dependent and independent variable. So what is dependent, which is the major thing we are looking at here, and what's the independent variable? In this function here, this f of x is a variable which can be written as y, and this s cube is also a variable which is same thing we have here. I get it. And we already said that variable can take any numerical value. So what is a dependent variable? Dependent variable is a variable that depends on other variables or something else for its value. It can't take any value it likes. I get it now. One independent variable, from the word independent, it can take any numerical value it likes. That's just a layman way of explaining that. Okay, so in this function here, what one is our dependent variable? Which one is our dependent variable here? If you look at this is our independent variable, and this will be our dependent variable. Same goes here, dependent. This one too is independent. Are you getting that? So in this question here, this is our dependent variable and this is our independent variable. Reason why is this one our dependent variable? Why is y our dependent variable? Because y here is our dependent variable. Reason because it depends on x for its value. That's why it's a dependent variable. I did say from definition. Y is a dependent because it depends on x for its value. Y cannot take any value of its own. but here x can take any value of its own. I get it now. Now let's look at it. If I say when x is 1 here, y will give us 1. So y is depending on the value of x for it to have its own value. I don't know. If I say x is 2, that will determine what y will be. That will be y will be what? 8. I get it now. So x can take any value it likes, y cannot take any value it likes. It depends on x for its value. I get it now. So here goes the saying of here goes the what we are looking at, which is dependent and independent variable. And how this is just basically what you need to know under this variable. It's very important. You need to know which one is dependent and which one is independent, especially when you are dealing with a calculus problem, ODEs and the likes. So this about that. So let's look at one or two examples on that function, and then from there we'll call it a day. All right, example now. Let's look at example. So let's say we have if we have what, let's say we have a function f of x equals to, let's say we have 2x squared plus 1, and then we want to solve this. How do we solve this? And they say you have to find f of let's say f of let's say you have to find f of 2. That's what you have to find. So how do you find f of 2? Very simple. From here, what do? You have just 2. Anywhere we see x, we'll put what? We'll put 2. This x, this is 2. So anywhere I see x, I put what? 2. So if I put 2 anywhere I see x, we have 2 here. X here is what? 2 square plus 1. So here you have what? 2 square is 4. 4 times 3, 8. That is 8 plus 1, which gives me 9. So this is how you solve problem like that. Let's say give an example. Let's say you have f of x equals to, let's say you have 3x squared plus 5, and say you find f of 0. So what is f of 0 in this case? So f of 0 is anywhere we see x, we put 0. So you have what? 3 multiplied by 0 square plus 5, and which this will give us what? Will give us 5. Do you get it now? So do you get the logic in this problem here now? So it's very simple and it's not difficult to understand. So let's look at maybe you have a composite function. Let's say we have a composite function. Let's say we have f of x equals to 2x squared, and we have g of x equals to 5x plus 1, and we have to find, let's say we have to find f of g, or let me put it this way, you have to find fog and you have to find gov. I get it now. And maybe I'll add one more example after this. So we have to find fog. What's the meaning of fog here? Fog here means f of g of x. I there now. So f of g of x. I there now. So this is f of g of x. So how do we find that? Very simple here. First of all, we need to find what is g of x. G of x is 5x plus 1. That is f of 5x plus 1. I get it now. So f of 5x plus 1. So from here, how can we solve this? We have f of x to be 2x squared, and we are looking for f of 5x plus 1, meaning anywhere we see x, we put what? 5x plus 1. And here, solving this problem now, we have what? 2 open bracket, anywhere we see x, we put 5x plus 1. So here we have 5x plus 1. Do you get it now? Square. And this will be our final answer. Do you get it? So it's very simple and very easy. Next question. Let's say we have a g of f of x. So what about g of f of x? Very simple. This is same thing as g of, what is f of x? F of x is what? 2x squared, right? So anywhere where I see x in g, I put 2x squared. Do you get it now? So yeah, we have f of g to be this. We have g of 2x squared. So anywhere I see x, I'll put 2x squared. So we have from our problem of g, we have from g of x, we have 5x plus 1. So we have x here, so replace with x squared, 2x squared rather, plus 1. And then this gives me what? From here we have 5 times 2, we have 10 x squared plus 1. And this is how you solve that kind of problem of f of g and g of x. And you can furthermore, there are more examples you can further try on your own. Also you can try this, and let me know your answer in the comment section. Let's say we have, if you have, what if you have f of g of 2, from the same question, from the same value of f of x and g of x. Try this and let me know your solution in the comment section below. Don't forget to like and also subscribe, share to those who are in it. So see you in the next video.